All right, so let's get started. We are solving systems by elimination. This is 5.3, and we want to write that down, please. And this is 5.3a because it's our first video on solving by elimination. So 5.3a, solving systems by elimination. And I'm going to be with you every step of the way, taking it nice and slow. I want to show you what systems by elimination is all about. So I'm going to give you an example, and I'm going to start you with an example, okay? So this example is 2x plus y equals 5. And then I have negative 2x plus y equals negative 3. Now I might ask you, in this example, what do you notice about this example? Do you notice anything special, anything cool, bad? What are you thinking? Thoughts? Lily? What are we thinking here on this example? So what a lot of my students are noticing is that what's going on here is that if we were to take these equations and add them together, well, first of all, why can we do that? Well, the reason that we can do that is because if you look at, let's say, this equation right here with the star, okay? You look at the negative 2x plus y, and you know that that equation literally equals negative 3, right? They're balanced. Do you see what I've done? I've drawn a little scale there. Would you agree that the left side here is equal to negative 3? This is negative 3, and this is negative 3, right? They're both the same, right? Left side and right side. So I'm going to go ahead and add these equations together. When I add all of this stuff, what does all of this junk, all of this stuff equal? What does all of that equal in the red? It equals negative 3, right? Yes? It equals negative 3. So just to recap, okay, these two things are balanced, okay, because this is right here. We see this with this star, right? We see this equation. So what I'm saying is that those things are balanced. So because of that, we can say that the left side and the right side of this equation are both equal to 3. So what I'm saying is that this thing right here is equal to 3. So I'm going to add these equations together. Let me just get rid of that red stuff for a second, because that's the concept. That's the whole big idea. And if you don't understand the concept, that's not ideal, but you can still get away with knowing how to do it, even if you don't understand the concept. I like to explain the concept so you know why you're doing what you're doing. I think that's a smarter way to learn math. So this is equal to negative 3. I forgot a negative sign there. So I'm going to get rid of that stuff for a second so that it doesn't stress you out while I do the actual problem. So you'll notice that now that I realize that this is what I'm trying to do, just add the equations, let's just focus on this skill now, okay? Whether you understood the whole balancing thing or not, I'd love it if you did, but you might not have. What do these two things add to? Positive 2x and negative 2x add to 0x, yeah? 0x? Okay, so I'm looking to see if you understand what I'm saying. Positive 2x and negative 2x is 0x, so I'm just going to put 0 here, straight up. Now I'm going to add the y's, okay? So could you tell me, Hannah, what the y's are going to add to? You said that earlier. 2y. 1y plus 1y is 2y. Okay, cool. And now over here, we've got this side, which is 5 plus negative 3, which is 2. Okay? And I've got this new equation, which really is just 2y is equal to 2. So hopefully that makes sense. So just, if you need to, pause the video, take a second to understand what's happened, and soak all that in. Okay, so once you add the columns down, you're just going to solve that new equation. So all I'm going to do here is solve this equation, divide by 2, and I've got y equals 1. We want to have y equals 1 for a number. Now look at the two equations. You got 2x plus y equals 5. You got negative 2x plus 1y is equal to negative 3. And once you have that, I want you to pick one of those equations. I do not care which equation you pick, but for the sake of this video, I'm just going to pick the top one. I'm going to take this equation, and I'm going to rewrite it over here. So I'm not doing anything but rewriting this equation. Exactly. We're going to substitute the y equals 1 into that equation. But you don't need to substitute like the annoying way. All you have to do is take this 1 right here and put it there. So everything else stays the same. This is actually a review because in substitution method, you do this. So what we're focusing on is everything on the right side of the screen. So just to like take away some of these visuals, I'm going to cover up part of the screen. So pause the video if you need to copy this down, if you need to understand what happened. But I'm going to cover up part of the screen so that you can just focus on what you need to focus on. This. So all we need to do is focus on that equation and solve that equation. So what I'm going to do is I'm going to subtract 1 from both sides. I'm going to have 2x is equal to 4. I'm going to divide by 2. I'm going to have x is equal to 2. So I have an answer that's x is equal to 2, but I also have an answer that is y is equal to 1. So when I look at my actual final answer box, my actual final answer box is 2, 1. And that is how you solve a system by elimination. So I think we might have lost the beginning part of this video, but what's going on is I'm telling you that you can add two equations together because equations are equal on the left side and the right side. So equations are balanced, so you're adding the same thing to both sides by adding two equations together. Okay? So that's where we're at. Let's move on and try a couple other examples. So if you just learned systems by substitution, you'll realize that you always have to have x equals a number and y equals a number. Because if you look at your original equation, okay, which was 2x plus y equals 5. So your original was 2x plus y equals 5, right? And you also had negative 2x plus y equals negative 3. The deal is we have two unknowns. We have this that's an unknown. This is a number that we don't know. And this is a number that we don't know, all right? Now, maybe in my class, you've been doing something like this. You did this thing with these like mobiles, and they kind of look like this. You had like a bunch of triangles here, right? And then you had like a triangle here and a couple of squares or something like that, right? And then we knew that it was equal to, I don't know, 18, let's say, for example. And if that's the situation, if it was equal to 18, there's two different things we don't know. First of all, we don't know triangle, right, which is all these guys, right here, right here, right here. And also we don't know square. We don't know square either. But we can pretty quickly find out that if this is 18, then this is 9, and this is 9. And triangle must be 3, 3, 3, right? So triangle, pretty quickly, we can figure out is equal to 3. Now, if that's equal to 3, how much is left? 6 for the squares, right? Because this is 9 and 9 here, right? 9 take away 3. So this is 9, take away the 3. So this is worth 6. So if that's all worth 6, the square must be equal to 2. So, I mean, we're trying to find two different things that are unknown. We're trying to find the red question mark, which is x, and the green question mark, which is y. So for that reason, what we need to do is we need to take our original answer, which was over here, y equals 1, plug it back in like this, and get our second answer, which is x equals 2. So always a system of equations will have two answers unless it's no solution or infinitely many solutions. All right, so we're on to our next example. This is our second example. So I would encourage you to pause the video and try this problem if you think you're able. If you don't think you're able, just let the video continue playing and we'll go through it together. So pause it and give it a shot if you think you're ready. So if you're that person that paused the video and you're giving it a try, you might want to just know the first step. Maybe you don't even know the first step. Just add the equations together. Because if you look at these, right, if you look at the 6 and the 2, they're not going to cancel out. If you look at the 3y and the y, they're not going to cancel out. But there's some magic happening here. The magic happens when the 2x and the negative 2x cancel out to 0. So I could put 0 here if I want, but this is the first step. So take a second, add everything together. So what I have is 8 plus 0 equals 4y, because there's an imaginary 1 right here, right? There's an imaginary 1. So I have 8 plus 0 equals 4y, but what's 8 plus 0? Straight up 8, right? Straight up 8. Okay, so we got 8 equals 4y. I'm just solving this equation. All I'm trying to do is solve this equation. Pause the video if you need to copy this, but I'm gonna cover up some of this. And I'm just trying to focus you in on what you need to know. All you need to know how to do is solve this. So divide both sides by 4, y equals 2. Now, are we done now, or do we have another one to find? We have another one to find. This is the word to the wise, people. You've got to take that answer of y equals 2 and plug it into another equation. So here's what I want to do. I'm going to do something. I'm going to take all of this stuff, and I'm going to shrink it down a little bit. Okay? I'm going to get it out of your way. I'm going to put it over here. Pick an equation that you want to rewrite. I don't care if it's the top or the bottom. Go ahead, Trey. The top. So we take the top equation and we rewrite the equation. 6 plus 2x is equal to 3y. It didn't matter whether I picked the top or the bottom. I could have picked the bottom just as easily. It's cool. But I decided to pick the top just for the heck of it, maybe because it has positive numbers. What number do we want to plug in for what variable? Yes?
You want to plug in y.
We want to plug in 2 for y. So this is the key step. This is actually no different than what we've been doing. The 2 has to go for the y. So this must be replaced. So I'm just going to put a 2 here. I'll put a times 2 because it's always multiplication. 3y is always 3 times y. 3 and y squished together, always multiplication. So this is going to be 3 times 2 in this situation. The 2x hasn't changed. The 6 hasn't changed. And that's a plus sign, not an x. So that's a 6 plus. Okay, I'm going to do the same thing I did before, so I'm warning you to pause if you need to copy this down. But I'm going to cover up everything you don't need to deal with. Okay? So I'm going to cover it up since you've already done all this extra work, and it can be a little confusing and overwhelming. All we need to do is solve this equation. So this is the equation we need to solve. So I'm just going to solve it the regular way. I got 2x equals 6, right? And then I've got, 6 plus 2x equals 6. I'm going to subtract 6 on both sides. I have 2x equals 0. X equals 0, okay? So we have x equals 0 for our answer, but that's our second answer. We also have y equals 2. So we know that our answers are 0, 2. If we wanted to put our answer into a final bubble, our final answer is 0, 2. How do we know it's right? Well, this is our x and this is our y. So I'm going to put 0 here and here. So 6 plus 0 and then 3 times 2, right? I'm going to put 2 here. I'm just kind of sneaking these in. That's going to be correct. 6 equals 6. And then here I'm going to have 0. I'm going to have 2. I'm going to have 2 minus 0. And then this is 2 times 1, which is 2. So this is going to be correct. So this is our final answer. It is absolutely correct by checking our answers, by plugging them back in. So hopefully this gives you the gist of systems by elimination. Now lastly, I just want to show you what to do if you're in a weird situation. Let's say you're in a situation like this, okay? You got 3x minus 4y equals 11. And then you've got, 2x minus 4y equals, that's 25, not 2x. You get 2x minus 4y equals, and I'll say just 9 or something like that, okay? So here's the deal. We don't know what to do because what happens if we do our normal thing? We just go like this and we add them. Does that work? Does that work? No. What's the issue? What's not going to cancel out that we want to cancel out, Rachel? The y's. We wish that we could cancel them out. So we got some work to do, unfortunately. We unfortunately have some work to do. So instead of taking those y's and just adding them now, what could we do to make the y's cancel out? What would we prefer had happened? What's our ideal situation? Good life. What would be good life right now? If one of them was positive, how can we do it? The only way we can make one of them positive is by multiplying by -1. So I'm going to do all this work here, and I'm going to take the top one, doesn't matter which one, and I'm going to put an x that's multiply by -1, okay? Multiply by -1, okay? You don't have to do the top one. You can do the top or the bottom, or you could subtract the equations, but I'm just trying to give you a set way that will always work. So I'm going to put mult by -1. Everything gets multiplied by -1. Every single thing gets multiplied by -1. That's a -1. That's -3x. That's positive 4y. That's -11. This guy, do nothing. Do nothing. That's 2x minus 4y equals 9. Okay? If you did it the regular way, it wouldn't really work because you'd get -8y when you add these. So when you add these, you'd get -8y, which is not eliminating. It's an elimination method. You want something to eliminate, okay? So every time, if you have numbers that aren't the same number, different signs, you need to make them the same number of different signs. But we're going to take it slow. We're not going to do very many of these yet, okay? Okay, so the final thing is I'm going to stop where we are. I don't want to take too much time here. But you notice that this equation that we've got over here, so this is not cool. This isn't going to work out. But what we're dealing with over here is now a doable problem. Agree? We add them together. It's a doable problem. This will work every time, but not always will you multiply by -1. Sometimes you might need to multiply by a different number, like 5 or -8 or something. But the idea is to get same number, different signs. Same number, different signs. Can you write that down, please? This is an important thing to have. Same number, different signs. And once you have the same number, different signs, they will eliminate when you add them together. Yes?
How do you know what number to multiply by?
The only way you'll know what number to multiply by is by using your critical thinking. If you have a 4 here on the top, let's say, for example, and this was a 2, well, we know that we'd want a 4 here, so we'd need to multiply by 2. Let's say the top number was like 8x, and the bottom was -4x. Well, we'd know, I keep writing a 2 instead of x. If the top number was 8x and the bottom was -4x, we're going to need to multiply by 2. Yep, and we're going to take it slow getting there. We're going to end the video there. Thank you for your time. Good luck. I'll see you in the next video. Peace.